Okay folks, I wanted to talk to you briefly about the graphic that we introduced in class, which I have reproduced here with a lot of boxes that hopefully will give you some guidance as to what I'm expecting you to do with this graphic. It's a roadmap. If you're asked to go from grams of a compound to the number of molecules, this helps you understand that you have to start at grams, you have to go to moles using the grams per moles value, and then convert to molecules using your 6.02 times 10 to the 23 molecules per mole figure that you all know about. So I want you to view this as a roadmap. You know right now that we have talked about grams, moles, molecules. We've not talked about liters, and that comes in when we talk about gas laws, so don't worry about those right now. If you want, you can print this graphic out and then put it on the back of your periodic table. I have indicated in the boxes what the conversion factors are that you're going to use when you use this roadmap. And an important one is this one, which only has a ratio symbol, a colon, that indicates that when you are going from one side of an equation, and I'm going to give you a very simple equation. This equation tells us that hydrogen gas plus oxygen gas yields what is known as hydrogen peroxide, essentially. If I asked you how many moles of peroxide would be produced with 3 moles of hydrogen gas, you would simply look at the ratio of the number of moles of hydrogen gas required to produce 1 mole of peroxide, which in this case is 1 to 1. Our ratio is 1 to 1. And when we use this in a calculation, you would simply write 1 mole H2 to 1 mole H2O2. So important to understand that moles are the key to all of what's known as stoichiometry, or the math used in chemistry.